Hello. Today we'll be talking about digital logic gate. So we have OR gate, we have AND gate, we have NOT gate, and we have NOR gate, and we have NAND gate. So if we take number one and let's talk about the OR gate, right? So the OR gate symbol will be looking like this. This is the output. It has two inputs. Let's name the inputs A and B, right? So these inputs, it is because it's digital, it's binary inputs, it's zeros and ones, right? So this logic gate has a truth table. If we write, let's say, if we write our own truth table here with different combinations of input. So let's say our A is our first input, then B is our first input. Then we have an output, right? Output here. Okay. So what will be our first input? Let's say 0. If we input on A0, we input on B0, what will be our output? These are fundamental rules that we are outlining now. So our output here will be 0. We will have nothing because there's nothing in. So let's say our A is 0, but our B is 1. What will we get here? So we will get 1 here. So if our A input is 1 and our B input is 0, what are we going to get here? We're going to get 1. So now if it's 1 here and it's 1 here, what are we going to get here? In terms of digital systems, it's zeros and ones. So 1 plus 1, it will be 1, right? So these are combinations of our inputs. So an AND gate, it adds the input, and an OR gate, it adds inputs. So the inputs are not depending on one another to get an output. So if we have only 1 on the input and then the other input is 0, then we will get an output of 1, right? So that's fundamental. So if we can say this, put it in terms of a circuit. So an AND gate will be a logic of 2 parallel circuits, right? Let's put a circuit here. Let's say we have a battery here. So a representation of a logic of an OR gate will be 2 parallel switches, right? Let's have a switch here. Let's have a switch here, and then here we have a bulb, okay, LED, whatever. So now let's say the first switch will be our A, our first input, and then the second switch will be B, our second input. So what will happen here is that if A is closed, right? If A is closed and B is open, the current will still flow through A to the bulb. So the bulb will be on, will switch on. So if our A is open and our B is closed, the current will flow across B switch all the way to the bulb, right? And then this will always be true. The output will always be true as long as one of the inputs is closed, one of the switches is closed. So the only time we don't have an output that is 1 is when both switches are open, right? When both switches are open, so we will be having here our bulb here it's not going to be on, right? So that's the basic fundamental of an OR gate. That's how it works, right? Thank you guys. Can you please help me with subscription, and if you like the video, and also like the video.